Good morning, guys. I'm going to go through some of these problems and see if I can sort them out for you. So I'm going to start with section 3 from the SAT, the practice SAT. You had questions on 4, 6, 7, 9, 10, 12, and 13. So here's number 4. It says if x minus 3 is a factor of the expression x squared plus kx plus 12, what is the value of k? So the hint here is to recognize that this is quadratic, and that if this is one of the factors, we know a couple of things. X squared plus kx plus 12 equals x minus 3 times something. Okay, so one way to figure this out is, since you've got just an x squared here, if this is x, this is going to have to be x. And then since this is plus 12, I know that minus 3 here is going to be multiplied by some number to add, to get up to 12. So that would have to be minus 4. Negative times negative to make it positive. 3 times 4 to make it 12. So then you can just expand this out, and you get x squared minus 7x plus 12. So if kx is negative 7x, then k is negative 7a. Another way to do it is to recognize that if x minus 3 is a factor, then x minus 3 would have to equal 0, or x equals 3 to give you a root. So you could just plug in x equals 3 to the original expression and solve, and you get the same answer. Okay. So that was number 4. Moving on to number 6. This one's kind of annoying. Okay. So they say the nth term of a sequence is given by the expression bn plus 4, where b is a positive constant. Which of the following is necessarily equal to b? SAT likes to do a lot of these kind of hypothetical numeracy questions, like understanding how well you know number theory and counting and stuff like that. But when in doubt, one major strategy that you can use when you have these theoretical questions, these abstract expressions, questions involving an expression, is just plug in the easiest number you know. So like, they're asking you to say what has to be equal to b, right? Well, just try a simple number. Like, I'm going to put in b equals 1. Okay? If I do b equals 1, then they ask several questions here about the third and fourth terms. So I'm going to do the first 4 terms of the sequence. So if n equals 1, 2, 3, 4, okay? And if b is 1, then 1 times 1 is 1, plus 4 is 5. If b is 1 and n is 2, that'd be 2 plus 4, or 6. If 3 is n and b is 1, that'd be 3 plus 4 is 7, and you get the idea. There's my sequence, okay? You could try b is 2, or b is 3, or b is 5, whatever. Just get yourself a set of numbers so then you can compare them to these things, okay? So is b the value of the first term? 1, 5. No. The difference between the fourth term and the third term, well, that's 1. That's b. That seems to make sense. I'm going to check the others just to make sure. The average of the first 3 terms, well, the first 3 terms, 5 plus 6 plus 7, the average would be 6. So that's not true. And then the ratio between the second and first, well, that's 6 to 5. That's 1.2. That's not it. Okay, so it has to be B. Okay, for number 7, this is one that I feel like we're going to have to review. We're going to have to go over some exponent rules to get through all of this. Okay, so basically what they're doing is they're asking you to solve for m. What is the value of m? Okay, well, m is to the 3rd power. That means I'm going to have to take the cubed root of that side, but we'll get there in a second. The other issue is that on the right-hand side, we have these different radicals. So one of the things that we're, I think, going to have to probably review is exponent rules as far as there's reserved to radicals, okay? So the square root of n, and where can I see this? I'm going to do this on the side. The square root of n is the same as saying n to the 1/2. Okay, the cubed root of n is n to the 1/3. Okay, so exponents, the number of the root becomes the denominator, and then any power inside becomes the numerator. It's a fractional exponent. Okay, so what this means is that when we look at this expression, the square root of the square root of n, this is n to the 1/2 for the square root of n raised to the 1/2 because it's square rooted again, which means that this is n to the 1/4. 1 times 1 is 1, 2 times 2 is 4. So again, I think we're going to have to review our exponent rules. So now I've just changed this to m to the 3rd equals n to the 1/4. To get rid of the 3rd power, you have to take the 3rd root, so that cancels out. So we get m, and again, now I have a third root. So that's the same as saying n to the 1/4 to the 1/3. Well, again, apply your power rules. 1 times 1 is 1, and 4 times 3 is 12. So this is n to the 1/12, or c. Okay, I think we're going to have to review that stuff. Okay, so that was number 7. Jumping down to number 9. So there's a lot of different ways that you can do this. One way is just to use substitution of the answers. So it says if 5 divided by m is less than or equal to 2/3, where m is greater than 0, what is the least possible value of m? This is important for us to, if we wanted to solve it algebraically, okay? But if you want to just plug the numbers in, 5 divided by 8 is 0.625. They want the least possible value of m, so like the way I would do it is just solve it. Okay, but I'd solve it slowly so that I don't have to worry about it. I'm not going to cross multiply per se. I'm just going to do it step by step. So I multiply by m on both sides. Then I multiply by 3 on both sides. Then I divide by 2. So m is 7.5. Okay, or you could just plug these in and find out what is the least possible value of m. The bigger the number, the better off it's going to be. Okay? All right, groovy. So that was number 9. Now we're going on to number 10. It's weird. I keep expecting you guys to be like, oh, thank you, or oh, I get it now, but there's no one here but me. Okay, so this one says, if f of x equals 3x plus n, where n is a constant, and f of 2 is 0, then find f of n. So this is a two-part problem. First, I have to solve for the value of n with this information. F of 2, the 2 represents the x value. The 0 then is the value of the function, or the y. So 0 equals 3 times 2 plus n. So we find out that n is equal to -6 when you solve. Now they want me to find f of n. So the function now is f of x equals 3x minus 6, because I solved for this. And then I'm going to take the n value, which is -6, and plug that in for x. So you get f of -6 equals 3 times -6 minus 6. That's 24. Just do a little bit of algebra. That's number 10. 2 more. Okay, here's another big issue, or looking at the problems that you asked about that I feel like we're going to have. We have not studied trigonometric graphs, or trigonometric identities, unless you had Mr. Ross freshman year. Okay, so I feel like this is something I'm going to have to do a little mini unit on in these next couple of weeks, to help you guys get some information on how to do this, okay? But the idea is that cosine goes from -1 to 1, and sine goes from -1 to 1, and they are periodic over 2 pi. So there's so many different ways to go about this, but for this one, for number 12, I would just say graph it, okay? So if you graph this function, so normally we would go from -1 to 1 would be the amplitude of a cosine or sine wave, but this is times 4, so that means it's going to go from +4 to -4. Okay, and then the other thing to understand is that pi is a radian degree measure. Pi, when we're talking about period or degrees, it's 180 degrees. So when you're setting your window on the calculator, you have to set it accordingly. So this is a situation that I would graph it, okay? So 4 times cosine of x, and then the other one would be 1, because it says in the problem, how many solutions does 4 cosine x equal 1 between x equals 0 and x equals 3 pi? Okay, so this isn't the pi of the 3.14159 variety. This is the pi of pi equals 180 degrees. So I can solve the equation this way, but when I go to my window, for my x-min, I don't like it to be just add 0, so I'm going to go -1, and then 3 times 180 is 540. my y's are going to go from -4 to 4. So if you hit graph, this is what it's going to look like. The blue is the cosine wave. It's periodic. It repeats itself. That's 2 pi. It starts at 4, goes down to -4, back up to 4. It's going to repeat. If I zoom out, just so you have an idea, this is what a cosine wave looks like. The sine wave is inverted, but otherwise the same. Okay, so I'm going to go back to my window. I said -1 to 540, and I said -4 to 4. Okay, so the question is, how many solutions does this have? Well, how many times does this curve equal 1? And then you're going to see the red line come through, and 1, 2, 3 times it intersects. So the answer there is 3. We're going to talk more about this when I do a review of trigonometric graphs. I think that's going to be really important because it came up a few times. And then one more. Oh, here's another concept we're going to have to go over, which is the idea of I. Okay, if I is the square root of -1, which of the following is not equal to I to the third plus I? So the idea here is that you're always looking for I squared. Because if I equals the square root of -1, then when you square both sides, I squared equals -1. Cancels out the square root. So we're always trying to make I squareds because then we can convert them into a number. Okay, so in this case, I have I to the third plus I. So what I'm going to do is I'm going to factor out an I. If I take one I out of I to the third, I'm left with I times I squared. If I take an I out of I, I'm left with I times 1. Also this, I squared equals -1. -1 plus 1 equals 0. Anything times 0 is 0. Okay? But the question is, which of the following is not equal to that? So now you have to go through the process and check the answers for these things and find out which of them is not equal to 0. Okay? Well, so the first one, you have 2I squared. So that would be 4I squared plus 4. Well, I squared is -1. So that makes this -4 plus 4, or 0. Then I have 2 minus 2 times I to the fourth, which is -1 times -1. Because I to the fourth is I squared times I squared. So that's -1 times -1, which is +1. So 2 minus 2 is 0. See where this is going. So then we keep on going and we get to C. And when we get to C, we get 2 times I squared, which is -1 minus 2. So that's -2 minus 2, or -4. There's your answer. That one's not equal to 0. So it's not hard if you know that I squared equals 0, or understand that from this little blurb they give us. But whenever we deal with imaginary numbers, we're looking to find I squareds, because those equal -1, and then just evaluate the function as best we can. All right, that is the problems from section 3 that you had. I will go over the problems from section 4 in another video.